Now let's look into the general approach to improve performance of any system, like be it hardware or software, doesn't matter. We'll talk about a general improvement of the performance. So there are a couple of common steps for any system improving performance in any system. First, we need to analyze and break down performance of a system into performance per independent module or subsystem. Okay, so if you, from software perspective, your software is composed of several basic methods and loops and decision making and so on and so forth. So their basic blocks are there. Now, among those module components, identify the largest performance bottleneck. Like if you are running a program, which component takes largest time, among which subsystem is taking largest time, and improve that part. That will affect, like that will improve your system performance greatly overall. And also try to make common case faster. It is kind of very intuitive, right? So if you know that one specific module or method or a component is being used repeatedly over time, then if you make that common case or common component faster, then it will definitely go and improve your overall performance of the system. Now, there are some pitfalls and fallacies. Like you expect to improve one aspect of the computer to increase performance by an amount proportional to the size of the improvement. I'll give an example. And another pitfalls is using a subset of the performance equation as a performance matrix. Like point is that like sometimes we forget to actually look at the overall system performance. We are so concentrated in the subsystem performance, we don't look at what impact is going to make if we change that subsystem into subsystem and put it in the overall system. So, and then we actually lose the global view of the whole problem space. So those are the pitfalls and fallacies of performance improvement projects. So we have one very nice law and theory, okay, and which is called the Amdahls law, and it can be applied to any kind of system, be it software, be it hardware, be it a mechanical system, doesn't matter. So it says that it's a theoretical limit for performance improvement. Okay, it's this theoretical limit. So your S is your speed up, and A, if now 1 is the full execution time of a program, and a B which is less than 1, let's say, like the full execution time, we are talking in terms of an unit, like full execution time is unit, like 1. And then B, which is less than 1, is a part which is improved by a factor of n. Okay, then overall speed up will be following, like S equal to 1 by 1 minus B plus B by n. So very easy to understand this part like this way. Like our previous full execution time was 1, and there is a B part of that, of within that 1 execution time, B part, which has been improved by n. So your B part is now taking n time less, but rest of the system is unchanged, right? 1 minus B, that quantity is unchanged, that quantity is not improved. So your speed up is not really by n, but your speed up is 1 minus B plus B by n. So that's the overall speed up of the performance. Now let's say take an example where is an which is an unrealistic expectation, right? So let's say a program runs in 100 seconds on a computer with multiple with a multiply operation responsible for 80 seconds of this time. So what's our tendency is to improve the multiplication process, right? Now you have been given a target that, hey, go and improve the multiplier such a way this program execute 5 times faster. You just manager told that, hey, I have 100 second total, 80 second out of that is multiply, go and improve this multiplication such that your overall program is going to execute 5 times faster. So my speed up S is 5, where we take 100 as, let's say, 100 second on the previous run. So we are improving on the 80 second part, right? So rest of is the 20 second is remained unchanged, and 80 second has to be improved by n so that my speed up is 5. So if we solve this equation, we can readily see that n is infinity. We cannot just improve multiply response time, multiply performance by infinite amount, like that's not possible. So with the use of the Amdahls law, we can say that this expectation is very much unrealistic, that we can improve the program runtime by 5 times. Like we cannot decrease the total response time of this program, that is 5 times faster, right? So means if you can think in a backward way, 5 times faster means your program has to run in 20 seconds, right? Now your multiply was responsible for 80 seconds of the time. That means rest of the program takes 20 seconds. What you mean here is that means multiply you are trying to do in 0 time, right? But multiply is a physical operation. You cannot do it in a 0 time, so it is not possible in that sense. So that's all for this performance related discussion. If you have any questions, send me email or ask me in the class.